Notes 4.6, finding equations of lines, day 2. So I know I told some of you to do notes 4.7, but as I looked at 4.7, I decided those would be the best to do in class together because there's a lot of discussion that we can have around those. So we're going to do 4.6, and we did some of this in class as a group, so that's good. So hopefully it'll be pretty easy, okay? So we're going to do 4.7 in class together, the notes, because a lot of discussion can be had. So the first problem, it says find the equation of a line that passes through -4, 7 and 4, 5. And it says graph the line. So if we've got to find the equation and we're given 2 points, we know we have 2 forms that we could use. Y equals mx plus b, which is our slope intercept form because we have the slope in the y-intercept. Or we could use our point slope form. Y minus y1 equals m times x minus x1. Okay, that's our point slope formula. Okay, but when we're given a graph, okay, we've got the graph right there. I would take and plot those 2 points. So let's plot those 2, and then let's make a decision which one we want to use. Whether we want to use the y equals mx plus b, the slope intercept, or we want to use the point slope form. So when I go and I plot -4, 7, that means I start at 0 and I go left 1, 2, 3, 4, and I go up 7. Okay, that's the point -4, 7. And then plot the point 4, 5 means go to the right 4 and up 5. Remember, you go right, left first, right? Then up or down. Grab that straight edge. Connect those 2 points. Okay, let's be real accurate with this. So I'm going to make sure that it goes exactly through those 2 points. Let's put arrows on it. We don't have the equation yet to label it because that's what the problem's asking us to do, is to come up with the equation. So when I look at this, I see that this line that I just drew in goes through the y-axis. That's the y-intercept. And then haven't we been working on figuring out what the slope is when we're given a line? We could do that rise over run. Well, I can figure that out too. I could go and draw in my rise over my run, and I would rise up 1 and go back 1, 2, 3, 4. Back means negative. So if I just found my slope and my y-intercept from my graph, well, that makes sense to use the one that is the slope-intercept form. So now we've just got our 2 blanks to fill in. So I'm going to set it up. Y equals blank, x blank. So let's fill in the slope, and let's fill in the y-intercept. So the slope is the rise over the run, so make sure that you know that your slope is up 1, back 4. So it's 1 over -4, x. Now that 1 over -4 doesn't matter where you put the negative. You can put it on the top, the bottom, or you can put it out to the side. It doesn't matter. It makes the whole fraction negative. And now, what was our y-intercept? Our y-intercept was 6. And it was a positive 6. So I've written my equation. Done. Okay, came up with that equation. The use of that graph is a big help. All right, let's look at number 2. Now, these graphs are kind of sandwiched together here a little bit. So I'm going to separate these 2. There we go. Okay. So again, it says find the equation of a line that passes through 2 points, and then it says graph the line. Did I label my equation back here? I did not. Well, we wrote the equation, so let's back it up and let's put that in there. Plus 6. Remember what I said, it doesn't matter where you put your negative as long as it represents a negative slope, you're fine. So what did we do? We started off and we plotted, okay, if we were given 2 points, okay, by all means, plot your 2 points. So 5, 8. Oh, that one goes off our graph. So we go right 5, and we're up here at 6, 7, 8. I'm going to extend that, okay? And that's okay. 5, 1. So we're going to go right 5 and up 1. Oh, why am I saying oh? What's happening here when we connect these 2 points? Okay, be real accurate. I need to shift mine over a little bit if I can. There we go. We still put arrows. And it's a vertical line. It's a vertical line. What do we remember about a vertical line? What axis does it go through? What axis does it go through? And you should answer it goes through the x-axis. It doesn't have a y-intercept. Never touches the y-axis. So now that vertical line, look what I'm going to draw. I'm going to make an N next to it. Why am I making an N next to it? Those vertical lines for the N means that there is no slope, okay, or it's undefined. Now I've got to write the equation because that's what the problem asked us to do. Find the equation. So what is the equation? It goes through the x-axis. Where does it go through the x-axis? This is 4, and this is 6, so it goes through at 5. So my equation is x equals 5. Remember, there was no y-intercept, so I don't have a y in my equation. Just goes through the x-axis. So it's just x equals 5. Done with that one. Okay. Some of you might have picked up on the pattern right here. What's in common? Right there. 5 and 5, done. X equals 5. It's a vertical line. Okay. All right. Find the equation of the line that passes through 3, 1 and 3, 8. Again, same type of question, and then graph the line. So we've got 3, 1, right 3 and up 1, and 3, 8. Again, 6, 7, I'm off my graph. But again, what's happening here? When I plot these 2 points, again, I've got a vertical line. And that vertical line, where does it go through? Does it have a y-intercept? Okay. So no y-intercept. I can draw that N, okay, right next to it, those vertical lines for the N, so it has no slope, and it goes through the x-axis. Right, and where does it go through? It goes between 2 and 4, so that's a 3 right in there. So x equals 3. Now hopefully some of you saw the pattern. We got a 3 there in our x spot and a 3 right there. Okay, so what is our equation? X equals 3. Make sure, whoops, I didn't put arrows on. Make sure you get your arrows and you put the equation on the line. Okay, go ahead and flip the page. It says every linear relationship can be represented 4 different ways. In words, in a table, in a graph, and in an equation. Okay, my favorite, or I should say I have 2 favorites. I like the table and I like the graph because they're visual. Okay. It says in each of the following examples you are given 1 representation and you must find the remaining 3 representations. Okay, So we've got scenario 1. It says, in words, a cable car starts at a height of 70 feet. That's the starting point. And is descending. Okay, so descending means it goes down at a rate of 30 feet per minute. Okay, so that's the in words. So let's go to the table. All right, so if I'm at time 0 minutes, no time has passed, I haven't started descending, what's my height? What's my starting point at 0 minutes? I'm starting at 700 feet. Okay, so now what about time 1 minute? 1 minute has passed, and it says I'm descending, I'm going down at 30 feet every 1 minute. So if I started at 700 and I'm going down 30 feet, that puts me at 670. Okay. Well, what about at 2 minutes? I started and I went down 30, and now I'm going to do the same thing. Okay, I'm going down at that constant rate, so I'm going to subtract another 30, and that puts me at 640. Well, let's do one more time. What about at 3 minutes? Okay, what's my height? I'm subtracting 30, so that puts me at a height of 610. Okay, like the tables. Now, what about the graph? So the graph and the table really go hand in hand, okay, because the table gives us the points to plot. Right? So time, that's on our x-axis in minutes. Make sure you label your units. And height along the y-axis. And make sure you label your units, feet. Okay. Right here, that's our 0, 0. Okay. Now I'm going to spread this out a little bit. You only have to go up to 3 minutes. So I'm going to say, I don't know, maybe every, let's see, that looks good, maybe every 3 boxes, just so we spread it out so we can really see it. 2 and 3. And we have to go up to 700 because 700 is our highest point. So let's see, 1, 2, 3, 4, 5, 6, 7, I'm counting, okay? I'm going to count by hundreds along the side. 300, 400, 500, you get the idea. Okay? So we start at 700. Change the colors here. Okay? At time 0, we're at 700 feet. So that's the point. 0, 700. 0, 700. There's our starting point. Now, what's the next point? At 1 minute, I'm at 670. Okay, so 1 minute at 670. Now we counted by hundreds, so we're going to kind of estimate here. We're kind of going to get close to 670. So 670 is a little bit closer to 700 than it is to 600. So about right there. And then at 2 minutes, we're at 640. At 2 minutes, we're at 640. Now 640 is a little bit closer to 600 than it is to 700, so a little bit lower. My smartboard doesn't do a great job at it because those points are kind of fat. And then at 3 minutes, we're at 610. 3 minutes, 610 again. We're not real close. We're not close to 700 anymore, but we're real close to 600. Okay, again, my points on my smartboard are kind of fat. Okay, so it starts here, and you could see how it's descending. Okay, it's going downhill, and you put that arrow on it. That if we don't put an arrow on this end because no arrow here. Okay, because that's where it's starting. That's our starting point. Okay, but we do put an arrow here. Okay, because that cable car is going to continue to go down. Okay, and the last thing, right in an equation. So y equals mx plus b. We know this information. We know the start, okay, that's our initial, and we know our slope, that's the rate that it's going down. So y equals, let's write it, where did we start? We started at 700, and then we subtracted 30x. But if I want to put it in y equals mx plus b form, we would say negative 30x plus 700. Either one is okay. Okay, either representation is totally fine. We're going to practice this more in class and do 4.7 as well in class. Nice job.